In this video, we're going to look at talking about parabolas, which we've already talked about in College Algebra 1, but we're going to take a different standpoint here. We're going to look at them from a geometric standpoint, just like we did the ellipses and hyperbolas, and look at what the geometric properties of parabolas are. So the definition is that a parabola is the set of fixed points in the plane equidistant from a fixed point called the focus and a fixed line called the directrix. So the equation, or sorry, the sketch would be, we've got some fixed point, some fixed line, and we take the set of all points, whose distance is the same from the point as it is from the line. So one of those would be the midpoint between the line and the point, between the focus and the directrix. And then the rest of them, maybe we would have a point here that's the same distance from the line as from the focus. Those distances look about the same. We can see that we're going to have symmetry like this. Right, and then the graph is going to look like what we are familiar with as the graph of a parabola. So let's take a look here and see what the equation is going to look like. So if we have a vertical axis, if the directrix is at, we're going to say y equals negative p, and the focus is at 0p, and the vertex is at 0, 0. The shape of the graph is going to be something like this, and we want to take any old point on here, x, y, and we want the distance from x, y to the focus to be the same as the distance from x, y to that line, y equals negative p. So the distance between x, y, and that focus would be square root of x minus 0 squared plus square root of y minus p squared. And the distance between that point x, y, and the line, y equals p, would just be y plus p. Right? Or we could say the square root of y plus p squared. These would have the same x coordinate. If we just drop this line down, that would have x negative p as its coordinates. So we'd have x minus x squared plus y minus negative p squared. Right? If we square both sides of that equation, we have x squared plus y minus p squared equals y plus p squared. And if we expand that, we've got x squared plus y squared minus 2yp plus p squared, equals y squared plus 2yp plus p squared. And then if we kind of combine like terms and get things to the same side, we could say wait a second, one of my y's turned into an x. it should be an x squared, sorry. So now we've got a y squared on both sides, so those cancel each other out. We have a p squared on both sides, so we can rearrange. We've got x squared equals 4yp. Okay. Or we could rearrange again. We could have y equals x squared divided by 4p. Right? All right, so that's the standard, what's called the standard form for the equation of a parabola with vertex 0, 0 and focus 0p and directrix y equals negative p. The focal diameter is the distance across through the vertex, sorry, through the focus. Let's see, the distance across through the focus, what we could try to figure out is when y is p, what is x? And we can see when y is p, we would have x squared is 4p squared. So x would be positive or negative 2p. So the distance across would be 4p. So the focal diameter, that's the distance across through the focus, is always 4p. If p is positive, the graph opens upward. If p is negative, then the graph opens downward. If p is negative, then your directrix actually is a positive y value, right? All right, so I want to put this over here, y equals x squared divided by 4p. That's our standard form. And then for a horizontal axis, if the vertex is 0, 0, and the directrix is x equals negative p, and the vertex is p0, your graph will open horizontally instead of vertically. The focal diameter is still 4p, the distance across through the focus. Opens right if p is positive, opens left if p is negative, and our standard form is x equals y squared over 4p instead of the other way around. All right, so the reason we try to get the denominator connected to this p value is because that will tell us how the denominator relates to the focus and the directrix. So it's a different way of looking at these than we did in College Algebra 1, but it's equivalent. So parabola has vertex 0, 0 and focus negative 2, 0. We want to find the equation, the axis of symmetry, the directrix, and sketch the thing. Let's start with at least a rough sketch so that we can see how everything's oriented. So the vertex is 0, 0. The focus is negative 2, 0. That means it's going to be opening leftward. And it also means that we're going to have an x equals y squared over 4p form. This tells us that p is negative 2 because the focus would be the non-zero coordinate of the focus is the p value, the way this is set up. So we've actually got the equation y squared over negative 8 using that p equals negative 2. The directrix will have to be a vertical line, so it'll be an x equals line. And it's on the opposite side of the vertex from the focus, the same distance away, so it would have to be x equals 2. And always write it as a line, not just a number 2. We've got the equation, we've got the directrix. The axis of symmetry always cuts through the middle. In this case, that's the x-axis, so y equals 0. And then sketch the thing. One nice way to get the sketch is through the focus, we know we want the diameter to be 8. So we can go 1, 2, 3, 4 this way, and 1, 2, 3, 4 this way, using the focal diameter to get a couple points. So we know that has to be 8 units. So 4 to the left and right, or up and down, sorry, through the focus. All right, next one. A parabola has vertex 0, 0, and directrix y equals -3. Find the focus, the equation, the axis of symmetry, and sketch the graph. So vertex 0, 0, directrix y equals -3. So a horizontal directrix, which means the graph is going to open upward. We also know the focus has to be the same distance on the opposite side of the vertex. So the focus would be 0, 3. And that's the value for p. The equation, since it's opening upward, we're going to have y equals x squared divided by 4p. P is 3, so y equals x squared over 12. And this tells us the focal diameter is 12. So if we go 6 to the right and left, we'd have this point 6, 3, and -6, 3 through the focus. We can connect those points in a parabolic way, and we've got a decent graph. So again, using the focal diameter, we could also just pick x and y values, or pick x values and find y values. That works too, but this is just a nice way to look at it geometrically. Axis of symmetry would be the y-axis, which is x equals 0. So I think that's everything, right? So the focus we have, the equation, and the axis of symmetry, and the graph. Here we're given the equation and asked to find all the pieces. So the focus and directrix of x equals 1/3 y squared. So if I just rewrite it for emphasis as y squared over 3, this is 4p. Because that's positive and because it's an x equals, we know it's going to be opening to the right. The vertex is 0, 0 because there's not any shifting or anything like that from our standard form. So 4p is 3. That means p is 3/4. If it opens right, the focus has to be on the x-axis. So the y-coordinate is 0, and the x-coordinate then would be p, which is 3/4. And the directrix would have to be a vertical line, so an x equals has the opposite sign from the non-zero coefficient on the focus, so -3/4. So focus 3/4, 0, directrix -3/4, and the focal diameter is 3. So through this focus we want to go 1.5 units up and down to get some other points. They didn't ask us for a sketch, but we can do a sketch anyway. The graph would look something like that. So the focus is 3/4, 0. The directrix is x equals negative 3/4. The graph would look like this. Same kind of question. Now we've got an x squared equals negative 2y. If I solve this for y, I'd have x squared over negative 2. So 4p is negative 2, which means p would be negative 1/2. So the focus, the non-zero coordinate, is going to be negative 1/2. We need to figure out if that's the x or the y. We solved this for y. That was the one that was not squared, which means it's going to be opening vertically, and because of the negative, it'll open downward. So that's going to be a negative 1/2 in the y coordinate of the focus, not the x. The x would be 0. And then the directrix is going to be a horizontal line. So y equals, with the opposite sign, positive 1/2. So that's not a very detailed sketch of the graph, but at least it helped us figure out which way things were oriented. In example 5, we're given a description of a satellite dish that is parabolic in cross-section, and it says the receiver is at the focus. The other information is given is that the reflector is 1 foot deep and 20 feet wide from rim to rim. So we can set up a coordinate system and try to get an equation for this parabola, that's the cross-section of this satellite dish. It says it's 1 foot deep and 20 feet wide. So that would mean if we set up the origin at the base of the cross-section, we would go 10 feet each direction horizontally and 1 foot up and down to get to the center of it. So in terms of our equation for this parabola, we would have a point that would be 10, 1 as a point on the parabola, and another point, negative 10, 1. And then certainly the way we set things up, the origin is the base of this thing. So 0, 0 would be a point. So the vertex, the way we set things up, is at 0, 0, and we need to know where's the focus. Okay, so what we can see is that we're looking at an equation of the form y equals some constant times x squared. And we know that 10, 1 and negative 10, 1 satisfy this equation. So I could put 1 in for my y and 10 or negative 10 in for the x. Either way, when I square it, I'm going to have 100. So we're looking at y equals 1/100th times x squared, or if we look at it another way, x squared equals 100 times y. So what we can see is that 4p would be 100. So the value of p for this parabola would be 25. And p tells us the distance between the vertex and the focus. Which is what we're looking for here. The question was, how far is the receiver from the vertex? And we're told that the receiver is at the focus. So the receiver is 25 feet from the vertex. And the location of the focus would be 0, 25. Moving on to example 6. We're told that we're given a parabola that has a vertex at 1, 3, and directrix y equals 7. So let's just sketch that much and see what we can determine from there. So the vertex is not 0, 0, so we have some shifting going on here. The vertex has been shifted 1 right and 3 up from the standard vertex at 0, 0. The directrix y equals 7. This shows us that the parabola opens downward. And that means p is going to be less than 0. Let me draw that again. The distance, make it in blue maybe, between the vertex and the directrix has to be the same as the distance between the vertex and the focus. If that distance is 4, we need to move 4 this way to get the focus. So the focus must have the same x-coordinate, but 4 less for the y-coordinate, which is going to make it 1, negative 1. So we found the focus location. The focal diameter is always 4p, or 4 times the absolute value of p. In this case, that's going to be 16. Could follow up here that p is actually going to be negative 4. Right. And then the equation of the parabola, we're looking at, because it opens downward, we know that x is the one that's going to be squared. But there's a shift, so I don't want just x squared, I want to shift it to the right, replace x with x minus 1. 4p would be negative 16. And then normally we would just have a y, but because we want to shift 3 up, we want to have a y minus 3. So we want to remember that left-right shifting will impact the x. Excuse me, if I move right, I subtract 1. If I move left, I add 1. And up-down shifting will impact y. And if I want to move up, I'm going to subtract from y. And if I want to move down, I'm going to add to y. So both of them are kind of opposite of how they look. So here we've got the equation for this parabola, and it asked us to sketch. We have everything in place except we haven't used the focal diameter. We want to go 8 to the right and left from this focus to get our key points. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So we've got over here this point negative 7, negative 1. And this point over here would be, 9, negative 1. Those would be points on our parabola. There you go. And I think that's everything for that example. Another example with a shift involved, so we don't have the vertex at 0, 0. Here we're told the parabola has focus 2, negative 5, so I'm going to mark that point. 2 to the right, 5 down. And directrix x equals negative 4. So this time we're going to be opening to the right. 1, 2, 3, 4. All right. We want the location of the vertex, the focal diameter, as well as the equation of the parabola. So this time, instead of having the vertex and the directrix, we have the focus and the directrix. The vertex has to be halfway between those two. So if we move horizontally and count the distance, 1, 2, 3, 4, 5, 6. So half of that would be 3. So the vertex, we can see, has to be at negative 1 -5. So the vertex location halfway between the focus and the directrix, -1, -5. Because this is opening to the right, we know y is going to be squared. So because we're also shifting down, I want to put y plus 5 squared instead of just y squared. We need to figure out what 4p is, but let's put y plus 5 squared equals 4p times, normally it would just be x, but here we'll have x plus 1 because of the shift to the left. And now we need to figure out, well, what's this value of 4p? Because this opens to the right, p has to be greater than 0. And because the focus and the vertex are 3 units apart, we can see that p is going to be 3. So 4p should be 12. So our equation should look like y plus 5 squared equals 12 times x plus 1. And then for our sketch, we want to use that focal diameter, and then we want to go half of that up and down from the focus. So 6 up to get this point, that's 1, 2, and 6 down, 1, 2, 3, 4, 5, 6. We'll just label that point negative, sorry, that'll be, I said this was 1, 2, but let me correct that, that's 2, 1. And this would be 2, -11. And then we'll sketch opening to the right. There we go. And then the last example, we need to take this equation that's given and rewrite it into the standard form for a parabola. So notice that the y group is squared, so we want to work on completing the square in the y's. So I'm going to factor out the coefficient on y squared from every term involving y. Leave a blank space to add something to that group. And I'm actually going to move the x and the 70 to the other side. So I'll have x minus 70 on the other side. Now, if I think about completing the square on this group, the y squared plus 6y plus blank, so that I want a perfect trinomial there, I ignore the 8 that's outside for now, and I say, all right, I want to add half of the coefficient on y squared. So in this case, that's 3 squared, or 9. And then when I wrote that 9, I really added 72 from 8 times 9. So if I add 72 to this side, I want to also add 72 to the other side to keep things in balance. So I'm looking at 8 times y plus 3 squared, rewriting that trinomial as a binomial squared, equals x plus 2 from negative 70 plus 72. And now if I get this in standard form, I'm looking at y plus 3 squared equals 1/8 times the group x plus 2. So 4p in this case is 1/8. Looking at the pieces they want us to find from this equation, we want the vertex, which we can tell just by looking at the shifting. We've got x plus 2, so we shifted to the left 2, and we have y plus 3, so we shifted down 3. We can get just a rough sketch of this so we can see where we need to move things. So the vertex is -2, -3. Because y is squared, we know this opens to the right or left. Because 4p is positive, we know it opens to the right. So something like that. And it'll actually be quite a bit narrower than that. So let me just sketch it narrower. So that's kind of the visual image we want to be thinking about as we put the rest of this together. Because p is positive, let's figure out what p actually is. So p would be 1/32 if we divide both sides by 4. So we want to move that direction to the right of the vertex to find the focus. So we want to add that to our x coordinate. So let's say -2 plus 1/32, -3. If we want to rewrite that, so -1 and 31/32, -3 would be our focus. The directrix would be a vertical line to the left of the vertex. If I subtract 1/32, that will be x equals -2 and 1/32. And the focal diameter is just 4p. Which was 1/8. So very narrow. Narrower than I've drawn it there. All right, good luck as you try to figure out these parabolas and think of them from a more geometric standpoint than we did in College Algebra 1.